Hi, my name is Jeff Coronado from JCSE, and this is a session in Bridging the Gap. For those of you who are not familiar with our sessions of Bridging the Gap, I invite you to visit our introduction on our YouTube channel. There you will see basically a little description of what Bridging the Gap sessions are, what their intended purpose is, intended audience, and basically how they're organized and what you can expect from them. This particular session is a session for the W17 series of sessions. And in particular, what we're going to cover is the outrigger efficiency. Okay, so with that, let's jump over to the detail that we in particular want to look at. And here it is. So this is, again, W17. It's an exterior non-bearing wall at the roof. You can see the rafters going in and out of the page here. Here's our stud wall. This is the roof sheathing. Okay. And in particular, we want to focus on the outrigger. Okay, so there is the specification for the outrigger, and here's the outrigger itself. So let's visit the outrigger for a second, just to make sure that we understand what we've got here. So the outrigger is this element here, and it's basically intended to support the roof as it cantilevers beyond the edge of the wall. So it's this area here. In this particular case, what we can notice is that look at how much of the roof cantilevers beyond the edge of the wall. And if we just kind of look proportionately, figuring that rafters are maybe spaced at 16 inches on center, which, so that's approximately what this distance is and this distance, we can see that the overhang here is not a whole lot. Okay, so we don't have much of an overhang, yet the outrigger is what I would say is a pretty healthy sized outrigger. It's 3x4, whereas maybe we might normally see more like a 2x4. It is flat, which means the longer dimension is horizontal than the vertical dimension. That's what we mean by flat. So it is kind of what we would refer to as in weak axis bending, right? Whereas this is the weak axis of the element, and this would be the strong axis of the member. So it is in weak axis bending. And then the spacing of the outrigger is 24 inches on center, which is not a whole lot, right? So sometimes you can see something, these outriggers be on the order of 2x4, maybe 2x4 flat, maybe spaced as far apart as 48 inches on center. So a 3x4 outrigger that's at 24 on center, that's a pretty healthy outrigger, right? You see that maybe for if the cantilevering portion of the span is a little bit longer than what this would appear to be. Maybe the roofing material is a little bit heavier up here, but the conditions here don't seem to warrant that. So for these conditions, I would say I would challenge this. I would want to see the engineer show me a calculation, because again, you want this outrigger to have a stress ratio, a demand capacity ratio. I'll just kind of scribble it here. A demand capacity ratio that's less than 1, but close to 1, right? So that means like a 90% stress ratio, a 95% stress ratio, maybe even 85% stress ratio, but not a whole lot less than that. Otherwise, we're being inefficient with our use of materials. So when I see a 3x4 at 24, I would say challenge. I would say I want to show you I'm asking you to show me the calculation so that I can see that you really need a 3x4 at 24 on center. Okay, so that's what we mean by the outrigger efficiency. Okay, so with that, let's jump over back to our session here. And yeah, with that, we conclude then the W17 Outrigger Efficiency. For other bridging the gap sessions that are related to W17 or to the detail that you just saw, take a look and look for other tutorials that are in the W17 sequence that'll cover other topics related to that detail. Feel free to leave us any comments, suggestions, or questions. If you've enjoyed this tutorial, please give us a thumbs up, and to stay current on other Bridging the Gap tutorials, subscribe to our channel so that you can be notified when we post new sessions. Okay, well, good. Thank you very much.